Hi guys, in today's video I'm going to show you how to debug network issues on Windows by using ping, IPCONFIG, TRACERT, and Nslookup and NETSTAT commands. My name is Yevgen and this channel is all about showing you how to become a highly paid IT professional and fast. Let's get started. The first thing I'm going to show you is what actually network adapters are and how many do we have. In our case, to do that, we need to right-click this icon here, network option, right-click it and choose Open Network and Internet Settings. After this, settings will appear. So settings is something that came with Windows 10, but as Windows 10 developers didn't implement everything in here, we'll be using an older interface. To open the actual network configuration, network adapter configuration, we press this button here that says Change Adapter Options. After we open it, we can close this useless one. Okay, so in here we just have one network adapter. As you can see here, it's named HomeNet. To rename it, I can right-click it and choose the option for rename. So something like Home, for example. Now let's look at the settings of this interface. So to do that, we need to press right-click and go to Properties. In here, we have a few options. The most important ones are IPv4 protocol and IPv6 protocol. In my case, I've disabled IPv6 protocol as I don't use it, and well, in my case, it's much faster to use just IPv4 and not expose my machine to IPv6 networks. So I will be configuring IPv4. You can do the same with IPv6, but some in different options. So to configure IPv4, I just double click or I press left click and go to Properties. And here we have two important settings. Everything else is not that interesting. So the first part is IP configuration. IP configuration is an actual address that other computers on your network can see you. This means that we can have our network devices on our network access this machine, and also this machine to access network devices on the same network or outside of the network. So in here we have two possibilities. We can use DHCP server and obtain IP address automatically. The DHCP server is just a server that gives you information about your IP address. So something that gives you the actual IP address that you will be using on your network. Another option is statical configuration. This means you can specify IP address and all the rest of the network information by yourself. The first option is good if you're having some specific and new computer that has everything working, so has a router and has the network infrastructure well set. When connecting one computer to another one, so if you just want to connect two computers at your network, at your home, you will have to use this option. This option might also be used if you have some specific devices that you need to configure. But in our case, we have DHCP server giving us the IP address information. So we'll do this option. Another part of this interface has DNS configuration. So DNS is Dynamic Name Service. So these options allow us to resolve domain names into IP addresses. What that means is when you access google.com, it actually goes to a specific IP address, because networks your computer need to use network, and your network routers on your path need to understand where you are trying to go. By just saying, oh, I want to go to google.com is, well, not saying anything. And saying, oh, I want to go google.com that has this specific IP address, like for example 1.2.3.4, then you will know and give the information to your network device, so your computer, and then your computer will go and send this information to your router, and that router send to other router, and so on. It will find the actual server you're trying to access and will give you a response and come back to your computer. So by default, you will have obtained the DNS server address automatically. This means that your router in your network or your direct ASP provider will give you these addresses automatically. This is good if you want to just use default DNS servers, but some ISPs, well, have really bad DNS servers. So the answer from the DNS server might take a really long time to get to your computer. So resolution names is something that you need to understand when you're trying to access the network. So for example, if you're trying to access some website and you see resolution not completed, you will understand that something went wrong. Well, actually, let's try this with something like with an invalid configuration, and let's actually see what our browser says to us. Okay, so I configured that, and now I'm going to try to go to google.com. So as you can see, we are trying to resolve the host, and it's taking some time. This means that our computer is trying to access DNS server and resolve google.com. As you can see, we have DNS probe finished bad config. A few moments before, the name was a bit different, but the idea in here is you have DNS problems. This means that we are not able to access the google.com because we can't actually resolve it. So we can't get an IP address of google.com. And the same thing happens if your DNS server is really slow. So imagine a provider that has a very old server for DNS and that has like 10,000 clients. This will actually impact your access to the network. You might have a good connection to the internet, but DNS server will not resolve your domains in time. This means you will be slowly accessing the network. So to do that, we might use public DNS servers. Let's go back there and configure one. The one I suggest is using Google one. Well, it might have some implications in the sense of Google is a company and they probably sell your data, but well, there are too much data going in there. So something like your DNS requests, well, it's not that much. In any way, we'll be using them. So to configure it, I will press 8.8.8.8 and 8.8.4.4. There are some different ones like Cloudflare, like, some security companies also provide you DNS servers. So if you like, you can choose others, but the idea is to have this configured to have your network working and in a faster manner. So obviously, if you are in a corporate network that requires you to use something specific, some local DNS server, then the issue changes. But in most cases, we will be using some home accessing a specific device outside of our network and using specific DNS configuration. Okay, so that's okay and okay. And we've got through there. Okay, now that we have this configured, let's see the actual status of the network. To do that, we right-click and open Status. And in here we have some information. So we have information about IPv4 connectivity. This means that Windows, this showing Internet, Windows can get access to the Internet. What this means is when Windows tried to get to Internet, it got to Internet. That means that your computer is connected to the Internet. The problem is sometimes Windows server might not be responding, so this might show no internet or something like that while you actually have it. Another thing you have here is no network access. So in this case we have IPv4 disabled. That means, well, we are not using IPv4. Media state is enabled. It can change. So if it's get disabled, if you disconnect the cable, it will show you cable not connected, and it will have a red cross on this side. We have the duration that is working, and we have the connection speed. And here we have the actual activity. So we are sending and receiving some packets. To get more details, we just press the Details button. In here we have some more information. So we have device name. In this case, it's a virtual machine running on Hyper-V, and so the device name is Microsoft Hyper-V Network Adapter. In home networks, you will see some other name like Realtek or TP-Link or something like that. Another very important part in here is MAC address. It's sometimes referenced as physical address, and it may be written in a different format. In this case, the address is like this. So every IP address, every MAC address is unique, and the initial part shows the provider of it and unique number from it. As you can see, it has some characters in it, so it's hexadecimal. Let's open Notepad and I can show you the actual information. So sometimes you can have something like this: 15, 5D, 01, 4D, 04. This is the same as saying this. There are just some different notations for the MAC addresses out there. Oops. Okay, so these characters can be from 0 to F. So 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. This means these characters can be something like this. So I can have a device like having FF, 1, 2, 1, 2, 3, 4, FD, BC, 1, 2, 6. Okay. So this is also a valid MAC address. Okay, perfect. So the other setting we have here is DHCP. DHCP means that we have the DHCP server running and we have IP address distributed by it to us. So we haven't specified static IP address. Now we have IP address, IPv4 address information. In here, you can see my IP address is 192.168 something. This part here means that it's in a local network. There are a few reserved IP addresses like 10.0.0.0 slash 16 or 16 here and 8. So what you can see here is CEDAR notation. So you can search for it and get more information about it, but it's just show you what's the beginning and the end of the network. This means that this network can go from 0.0.0 to 10.255.255.255. So this 8 means the number of bits for the network part. So as you may know, IP address has 32 bits. So 1, 2, 3, 4, 6, 7, 2, 3, 4, 6, 7, 8. This means we will have something like this. So actual IP address has 8 bits of information. And in this case, we are saying that our network part is just this bits. In our case, 10.0 is, well, it's 8 plus 2. So if you remember binary, it will be something like 0, 0, 0, 0, 1, 0, 1, 0, and yeah. So 10 in binary is this one. This means we have here 1, 2, 4, 8, and here we have 16 and 32 and 128. Well, but that's not really important. The important part is we have this saying that this part will be the network segment, and all of these IP addresses are valid for our hosts. This means our network can have all these IPs for the actual computers or different devices. Other type of network is the normally used one, 192.168.0.0/16. This means we have something similar. So we have this part for the network and this part for the actual computers or hosts on that network. This is important because we need to understand where our network begins and our network ends. So our subnet mask is something that also gives us this information. So our subnet mask in our case is 255.255.250. This means that our subnet mask is something like this. So as you can see, this whole sum will be 255. Same thing for here and same thing for here. And so our network is /24 because we have 3 parts of 8 bits being 24. So 8 plus 8 plus 8 is 24. This means this is 8 and this 8 and this 8 and this is 24. So a net mask of 255.255.255.0 is the same thing as cder/24. Okay, I hope that was clear enough. But once again, this is something very specific that you can search there and find information about. Okay, next thing we have lease information. So DHCP server has configuration based on your MAC address, and your MAC address is static. But imagine your network is bigger than the number of computers on it, and sometimes you need to have your computer shut down. And well, there might be not enough IP addresses to distribute over all the network. That's why we have this part of these options. So the information when was it obtained is showing when was the IP address obtained. And it's valid till Friday, so just one day and a few hours. In our case, it's valid for just one day and something. So in this case, it's important to understand that DHCP server is giving you your lease for specific time frame. Okay. Another very important part is default gateway. This means this IP address is actually the one you'll be sending your packets to when you want to send something outside. So imagine you want to go to google.com that has IP address of 1.2.3.4, just an example. So you and in your network have 192.168.1.108, and you'll be connecting to your gateway 192.168.1.54, and then you will have the internet connection, and only then you will connect to your actual IP address of google.com. This means you have a few hops, and your network and your computer need to understand how to get outside of your network. So how to get to the internet server google.com. And this it knows by having a default gateway. Obviously, your router also has some specific default gateway, and that router also has different default gateway. The thing is, some different enterprise devices allow you to configure what actual network information you are exposing. So for example, if you would like to access someone on 192.168.1.109, for example, you will have to go through once again your router, so your network device, and it will see, oh, this is the network I know, by using the subnet mask or CDR notation, and it will understand, oh, this is part of my network, then I will show you the way how to get in there. So these two computers will just need to connect through another device, so through the actual router. And if it goes outside of your network, something like IP address that this router doesn't know, it will just send it outside of its network. Okay, the DHCP server is, well, the same one, so we just have some specific information about it. And then we have DNS servers. The DNS servers we've just cleared up. Okay, every other option is not that important for our case. Let's close this, and let's close this. Perfect. So now let's see the same information but in console. Consoles are great because they provide the actual information and allow us to see actual information without clicking 100 buttons. To do that, we just press Windows, write cmd, and we can launch it. In our case, we don't need administrative privileges because we'll be just looking at some, well, not very critical system information. Let's start with something simple. So, as we see here, we need to know what configuration do we have at our device. To do that, we'll press IPCONFIG. We'll write IPCONFIG and have just the information we are looking for. So, first thing we notice is Ethernet adapter. Ethernet means that it's actual physical adapter. So I have a cable connected to this specific device. And in here we have our name of the device. Then we have DNS connection-specific DNS suffix. This is something that we'll be looking into when trying to search for DNS information. But as we are using some other DNS server, this is not important. Then we have IP4 address, subnet mask, and default gateway. So the same information we've seen before. Okay, so this shows us some information. But if you would like to get more information, we can just write ipconfig/all. This will allow us to see all the information we have here. Notice one thing, it added some information. So in here we have host name and some more information that is not important for us, but might be important when you're debugging some network problem. Then you have all the rest of information that we see in that description box. Once again, name of the device, physical address, so MAC address, IP address, subnet mask, etc. Okay, first thing we would like to do is understand if our gateway is working. So as our gateway will be our exit to internet and to our network, we need to understand if it's working. As it's local network, our default gateway will be always answering our questions. And how to ask questions of the status of our gateway? We need to write ping. So ping command sends a packet to a specific server that we specify and expects an answer. So let's do this. As you can see here, we have information that we are pinging some IP address with 32 bytes of data. This means we have 32 bytes of data being sent to our IP address that we provided, so our default gateway. And then we have replies. This means that our default gateway received the request and replied to us with the same information. And first time it took 6 milliseconds, and time to leave of the packet was 64 seconds. So in this case we have other information, so the time is less than 1 millisecond for the next responses. And we have statistics. It's very important to look at here when you're doing something like that. So when you have done a few requests, you will have the number of ones sent and the number of received. So this means we have sent 4 packets and received 4 packets and lost 0 packets. Imagine if we would have some network issues on our network, then we will see the lost packets count and the percentage of that loss. This means there are issues over the network that we should be looking at. Obviously, if you'll be looking some other IP address outside the network, this loss might be different. Another thing is the round trip time in milliseconds to get to our router and to get the response. The average was 1 millisecond because 3 of them were less than 1 millisecond. Okay, so now we've pinged our default gateway. Let's ping our DNS server and see if it responds. As you can see, it's also responding, but notice 2 things. So this IP address is not part of our home network. So by default, ping increased time to live. It understands that it will be a bit outside of the network, so it will be further away from our network, so it increases time for the packets to live. The same thing appears with the byte size. I mean, the byte size stays the same, but the time of the response is different. Okay, just out of curiosity, let's check what our DNS server, if we change the default settings, will be doing. How much time will it take to respond? So to check this information, we have to go to ipconfig/all, and we have our DNS server. So our DNS server is the router. Actually, in this case, it will be just using our router, but our router has its own DNS settings. So obviously, if we ping it, we will get some information. But in itself, it will also search for some specific DNS server. And in our case, it might be someone from ESP. So something from ESP might not be that great. That's why we will be changing it back to Google's ones. Just 1 second, and let's go here. And once again, use 8.8.4.4. It's actually curious because some network configurations might actually specify you with DNS server configuration. So you will know something that not from part of your network, so not your direct router, but something outside of the network will have the DNS server configuration. Okay, in any way, now we've seen some pinging. We've seen something that actually responds to us. Now let's ping something that doesn't respond to us. For example, 8.1. something random. Hopefully it wouldn't respond to us. Yeah, it doesn't respond. So in this case, we have request timeout. This means that it lived, we sent the packet, but we didn't get the response. So in time to live, it didn't get the response. And in this case, we have sent 4 packets, received 0, so our loss is 100% because 4 packets were lost. This might indicate that there is a problem with our server, or it might be blocking ping requests. So some servers block ping requests because they don't want to appear as online. This is because some people use network scanners like Nmap to understand the status of the servers, and with that they can actually continue the attack. But if the server doesn't respond to pings, they might think that, well, the server is probably offline, so nothing to do there, and they will skip the server. Obviously, the tools are getting better and better, and that verification of the status of the server can be done by the other means. But let's continue with that. So let's now see how domain resolution works. As I was saying, for example, google.com has an IP address. It actually has many different IP addresses, but we'll get into that a bit later. But when we want to get an answer from our server, for example, google.com, we can use ping once again with a domain name. So in this case, we're pinging google.com directly by its domain name. Behind this, it will actually do the resolution, so it will resolve to an IP address. So this will resolve to an IP address and then ping the server. That's why we had DNS server configuration. That's why we are receiving some information. So in this case, we see that IP is this one, and once again, when trying to ping it, it got the answer in 11 milliseconds. And well, this means that the time is to get to the server is 11 milliseconds. Obviously, different servers in different locations will have different times. Okay, now let's look at other command that we need to understand. The second command we need to understand is Nslookup. So Nslookup is a tool that allows you to check NS server configuration. This means name server lookups. So for example, we would like to see what IP address from google.com there is. So we write Nslookup google.com and we have the information. So in this case, we have the following information. The server we are using is DNS from Google, and IP address is 8.8.8.8. And we have information about the name, so the thing that we requested, and 2 IP addresses. The first one is IPv6 address, and the second one is IPv4. you may notice that this is different from the one that we were pinging. This is because DNS servers might have configuration based on what people are requesting. This means that if we request something that is, well, let me show you actually more in-depth option. So Google.com actually has many different servers, and if we check the request and repeat the request one more time, we'll get another answer. This is because there are many people requesting Google.com, and we have DNS balancing on this domain. This means that there are many different IP addresses that can get us this information, and we can get to Google by accessing one of those IPs. Okay, another thing we can do is get actual information about other parts of DNS. So DNS might allow you to get information about mail server and name servers. To change this information, to look at this information, we might write Nslookup and specify the type of the request we are doing. So NS server, name server, is something that will give us information about what specific domain servers know where this IP address can be given. So, for example, if you search for google.com, we will see different name servers. This means if our main server, so 8.8.8.8, will not know the answer to this question, so when we nslookup for IP address, it will give us more, it will have to request one of these name servers the information about that. This means the DNS server works in a recursive way, so if we request something that our DNS server doesn't know, it will need to find it, because it will need to give us information. And something like this has a very small, somewhat small timeout. So if something changes, the answer will be different in that case. Okay, another option we can see here is specify an A record. An A record is IPv4 address. This means we might want to get just the IPv4 address. So not IPv4 and IPv6, but just IPv4. We can go another way around by specifying 4 A's for IPv6 address. So as you can see, normal IPv4 address, but IPv6 address. Another thing there exists is MX records. MX records are mail exchange records. So we can look up for type equals MX, for example, google.com. Oops. In this case, we are looking at information about mail servers that will receive this mail. So, for example, if I send someone some email for someone at google.com, this email has to be delivered to specific IP address, but MX allows only to specify domain names. This is because of, it's much easier to have a domain name with different IP addresses. But when this information is provided, MX information, it will then resolve this domain name to an IP address. So in our case, it will be looking like ns type equals A. This means to get our mail to someone at gmail.com delivered, we will have to send our email to this IP address. Okay, so now we have the basic understanding of how Nslookup works. Obviously, we can get into it, look up. Inside here, we can do the actual requests, for example, google.com, and we'll get the answer. But, it's a bit easier to use just directly with the command like this. Okay, to exit, we just write exit, and we are out of it. Okay. So we've seen ping, IPCONFIG, and nslookup. There are two more commands that we would like to look at. The first one is traceroute. So when you remember that when I was saying that you need to get through your router to get outside of your network. Let's see how this happens. So TRACERT command allows us to trace our network path over the network. So for example, if I would like to access my router 1.254, this TRACERT will give me information about the path that it needs to get to my router. This means that it will trace the path, trace the route to a specific IP address that I provided over maximum 30 hops. That means it will at maximum accept 30 jumps and will give me information at 30 jumps. What this does behind the scenes is pings the IP address and gives me information about the time this IP address is responding. So for example, if I TRACERT for something in my network, once again, let's see if I have something here. Hopefully yes. Nope, probably not. Just 6, no, maybe 5. Nope. Anyway, so it looks like I don't have any specific devices in here. There are tools that allow you to see and ping all your network, like Angry IP Scanner, that will actually fastly scan your network and see the status of your devices. But well, in this case, I was just showing the example. So let's trace route to something outside of our network. In any case, if it will be using our local network, it will just go through here and get to our IP address. Let's get into something that is not that far from us. I'm currently living in Portugal, so some .pt websites will be near me. Obviously, some US sites will take much longer time to respond to me. So let's TRACERT for a specific site called sapo.pt. Once again, it will resolve to an IP address and only then start the process. As you can see, the first hop is our default gateway. Yeah, so that makes sense. Every time we want to get out, we need to go through our default gateway. The second IP actually got request timeout. That's interesting. So in this case, we see the second host is not responding to our pings. This may be because it's overloaded or it doesn't want to respond to our pings. Let's try it once again to see if what's the case. So if we now get an answer really fast, and then the device is probably not overloaded, just doesn't want to respond to us. We'll just wait for a few seconds for it to time out. So the process is simple. So it requests an IP, it pings the first IP address, then sees the response time. Then it pings the second one and comes back and sees and shows us the response time. So in our network, we can see that we have 7 IP addresses. That means we have 6 hops. So 1, 2, 3, 4, 5, 6, and then the 7th hop will be our IP address. This means that our path to the website sapo.pt is first this IP address, then something unknown, then this 4 IP addresses. So to get to sapo.pt, I had to go through all this paths. Now let's look for something like google.com. Actually, Google has local servers. So in all countries, and at least most of them, has local servers. So the path might not be that different. And when this is ready, we should see some results, hopefully. And let's see. So in this case, as you can see, we are having timeouts with our requests. Oh, actually it works. And it's actually really fast. Obviously, it's going a bit further. So sapo.pt is something local, but google.com will be something a bit further. So as I was saying, there are servers from Google in all over the world. So they do this to have the network do faster requests. But as we can see, it's not as fast as our .pt friends. But let's look in something more even further. So TRACERT nsa.gov. By the way, while doing so, this will not be like logged. Nothing will happen to you. So we're just pinging the servers to get to nsa.gov. Oh, actually, we have this IP address popping up finally. So looks like it was overloaded with pings. Okay, And as you can see, something like nsa.gov that, well, appears to be further away has a very long, latency. So it takes 70 milliseconds to actually get to there. And as you can see, the paths will be similar. So telepac 14 with 195.242 and cprm something.net will also have the same IP address. So in this case, we have this same routers because our actual ESP provider has to go through them to get outside of this part. So as you can see, only the fifth IP address is changing comparing to the last one. Okay, so this will allow you to ping the hosts until you find the specific one that you're looking. Obviously, if some of the servers are not responding to pings, like for example happened like in this time, they might not give you an answer. But this will give you specific information when you're on some specific network to understand what is wrong and what address is not resolving or not pinging. Okay, and another command that we will like to look at is NETSTAT. So NETSTAT is a command that allows you to see information about the current network status. We just press enter, and in here we have something interesting. So what active connections do we have on our computer? We have some established connections, so state established. We can have something that is already just staying there, that is timed out and just closing the connection. And we have a few other different statuses, but the most important one is established and listening. So in this case, we have established connections. That means this our local IP address. So this is our local IP address. So before we continue, when I ping this IP address or when I reference this IP address, I'm talking about myself. This is done because the device might not have a local network, but it might be important to connect to itself. So to do this, Microsoft and other network operators suggest to use this IP address. So when I'm pinging this IP address, or when I'm trying to connect to this IP address, or when I'm doing requests to this IP address, I'm be talking to myself. So I'm be connecting to my own computer. And this means that we are listening on this IP address and this port. This means that someone trying to get outside of our computer will not be able to connect to this. And this means that we are looking in this port, specific port. Same goes for this ones and the rest of them. And here we have the different connections. So local IP address is actual the one network. And well, foreign address is where we are connecting. Protocol can be TCP or UDP. In our case, we just have TCP connections to a few different servers. As you can see, we have this information here. Actually, HTTPS is not, well, a number of the port. HTTPS is port 443. And so it helps you to understand this specific interface. Let's look at NETSTAT once again. And now let's do something different. So let's ping a specific IP address and let's make it run forever. As you can see, we're just pinging. And now we have, well, actually it didn't do because we are not using TCP or UDP protocol. But now we just wanted to show you the minus T command. And here we have different more connections. And now let's see something different, like for example when using the browser and opening a page. So for example, going for sub.pt once again, and let's see. And here we have a few connections. Some of them are actually the Chrome already opening them. And so we open this and we see many more connections being done. So SAP host on HTTPS, GS host on HTTPS, and we have some established. As you can see, some are closed wait and some are timed out. What this means is established are the ones that we are connecting, that we are currently using. Time wait are still waiting for, well, timeout, and close wait are waiting to be closed. Let's press this once again, and as you can see, we have a lot more connections. Some of them will be closed, but some of them will be established. This happens because sapo.pt has a lot of different JavaScripts being requested and, well, a lot of information. But as you can see, SAPO and, well, something different like 730, what is this? And some of them, yeah, videos too make sense, but, well, it might be difficult for us to understand. So domain name is a great way to understand where you're going in some cases. Sometimes you will need to have information about the IP addresses. To show the IP addresses, you might write -n. So as you can see, the command ran a bit faster, and now we have only IP addresses and ports. So it's not resolving the IP addresses to domains, and ports are the same ones that we're just looking into. So nothing specifically saying it's HTTPS. It does says it's HTTPS, but in a different way. Okay, and I suppose this is basically it. Obviously, there are some tools like cports that you might use. So this is also another tool that many different system administrators use. Let's download it, 64 version. And that also shows this information, but in a bit clearer way. So let's extract it and let's open it. It also shows us a bit more information. So in here you can see that what actual process name is using. What actual process name is using, its process ID and local port and all the information that we are looking at, but with, well, more context. So in here we have some random connection to some other random IP, but with cports we can actually see what process is connecting where, and, well, some information about that process. So this tool is also great when you're trying to understand what's connecting where. Obviously, some malicious applications will not show this information, but that's another question. And here we see something interesting. So this IP address says that local IP address is 0.0.0. This means that as the same as 127.0.0.1. In this case, it's all zeros. Is saying that all zeros is any network device. So this means our local computer, and this means any local IP address. So for example, in our case, it will be just this two, 127.0.0.1 and 192. So this references to something like all the IP addresses on our computer. And here we can also see some more information like, well, where is it? Actually, this one also shows all the IP addresses, but in IPv6 format. So instead of zeros, it has two points. Okay, and as you can see, there is also a TeamViewer service just running here. Okay, and another tool that I was saying about was Angry IP Scanner. That is a great tool to understand what's working on your network. Well, it's legacy. Let's just download the older one. Nope, no ads for me, thank you. Yeah, and as soon as it downloads, I can show you. So this is a great tool to find active network devices on your network. So for example, unlimited.0. Just confirm. IPCONFIG. It's 1. So 1.2.1.255. And this will scan all the network IP addresses, ping them, and see if they're alive. So in this case, looks like nothing else is alive for now. And 164 is alive. So it's one of the IP addresses that's actually working on our network. Obviously, 108 will be the one that we are using, so that's why we have 0 milliseconds. And 254 will also appear here because it's our gateway. And just in a second. Okay. So as you can see here, we can find network devices on our network. So live hosts are just 3 active machines in here. Obviously you have different filters, you have different options, you can scan ports, you can just show, only a live port, a live hosts. So it will just show you those IP addresses that are actually alive. So we'll take a few seconds. and will show us, once again the same information, but without the red ones. So this tool is really great to find hosts on your network. Obviously, let's stop it. Obviously, this information is also present in your router. So if I go to my IP address of my router, 192.168.1.254, I will be present with a panel, with admin panel requesting me my username and password. And here I can configure some options. But this video is not about this. Anyway, I hope you find this video useful, and thanks you for watching. Check out the video on the right for more content to help you develop your IT career.